Hey, welcome to Section 9.3, non-positive exponents. Today we're going to be looking at expressions that have non-positive exponents and really what that means as far as the actual value of the expression. So, first of all, non-positive exponents, we're really talking about exponents, obviously, that are 0 or negative. All right, now I want to look at it, or I want to investigate a little bit as to what this might be by looking at positive exponents and what happens. So let's just start off with easy one. We're going to be looking at powers of 2. And I'm going to start off by using a calculator, and then we're going to see if we can't see a pattern here. So if I look at 2 to the 5th, and you're going to have a hard time seeing that, but 2 to the 5th is 32. Okay. Now we get 32 in this case by going 2 times 2 times 2 times 2 times 2. All right, 2 times 2 is 4. The other 2 times 2 is 4. 4 times 4 is 16, and then we have 2 on the end there. Now, I kind of mentioned it, but if you look at 2 to the 4th, that would be 2 times 2 times 2 times 2. Okay, and so the first pair gives you 4. I'm going to even write that there. Second pair gives you 4. And then when you multiply those together, that's going to give you 16. And that's actually 2 to the 4th right there. 16. Okay? Now let's try to see, how do I get from 32 to 16? Okay? And let's look at exponent-wise what really happens here. So in these two problems that I've just done, all right, we had a number, and it was 2 to the 5th, and then I took away one of the 2's that we were multiplying by, all right? And when I took away one of those 2's, it was kind of like, I took 32 and I divided a 2 out of it, because that's what I did. I got rid of that n2 to give me 16 instead of 32. So that would stand to reason that if I'm going to go from 16 and I'm going to go 2 to the 3rd, okay, 2 to the 3rd is going to be 8. I'm going to divide 16 by 2 to get to 8. All right. Now let's keep going with that. What's 8 divided by 2? Well, that's 4. And then what's 4 divided by 2? We get 2. Okay. And that all should make sense. And maybe you know a couple of those by heart. A lot of people get tripped up by the 2 to the 3rd, and they don't really see that as being 8 right away. But some people catch on to that. And obviously, if we were to keep going upwards on this list, 2 to the 6th would be 32 times 2, because you're just adding another 2 to this list here. Okay? Now, if we look at 2 to the 0, you can try to get complicated with it, or just keep going with our same pattern here. So I divided by 2, divide by 2. I'm even going to put that here. Divide 2. Divide by 2, divide by 2, and that pattern continues. And for me to get there, I want to do the same thing. I want to divide by 2. So this is an exponent of 0, and it's 2 divided by 2. Well, 2 divided by 2 is 1. Okay? Now, we can keep going, and we're going to today. If we look at negative exponents, so all I did in all of these was decrease the exponent by 1, and that's all I've done here. Well, it would make sense that I would say all I want to do is divide by 2. Okay, I'm taking one more 2 out of there. Well, what is 1 divided by 2? Okay, it's 1/2. I can keep going. 1/2 divided by 2. Well, 1/2 divided by 2, if you have to use a calculator, you can, but you should get 1/4. Okay? 2 to the negative 3rd. And we're just going to keep dividing by 2. Cut a 4th in half and you get an 1/8. Okay? And we're going to end with 2 to the negative 4th. Okay? 2 to the negative 4th is cut 8 in half and you get 16, so it's 1/16. All right, now what are we noticing is happening here besides just the divide by 2 part. Okay, that's the easy part to see, and it's not really what I want to focus on. I want to focus on this thing right here. So I notice that this is 1/2, and this is 2 to the negative 1. What about 2 to the 1? Okay, 2 to the 1 is 2. 2 to the negative 1 is 1/2. All right. 2 squared, or 2 to the second, is 4. 2 to the negative 2 is 1/4, or 1/4. And that's the big part here. If you notice, 2 to the third is 8. 2 to the negative third is 1/8. All right. If you can't see it, we're starting to get a pattern with that number and that number. Okay, that one there and that one there. Here and here. Okay, so it stands to reason to just think, with what we've just looked at, that anything to a negative power is just going to be 1 over that thing to a positive power, and that's going to be our rule. We do have 2 rules here. So let's think of the 0 exponent rule. Let's try to figure that one out. So when I raised 2 to the 0, I got 1. Well, let's think of, what if I had 3 to the first power? Well, that would be 3, and 3 to the second is 9. How do I get from 9 to 3? Well, I just divide by 3. So let's divide that one by 3 to get 3 to the 0. Okay, 3 divided by 3 is 1. So, and you can try this with as many numbers as you want to, and this list right here is pretty easy to make, and every single time you're going to get that 1 right there. And that's really cool, is that anytime, and I'm just going to write it as our rule here, that anything raised to the 0 power will be equal to 1, or equals 1. All right. And, you know, in mathy words or in mathy writing, that would be something like a to the 0 equals 1. No matter what a is, if that thing is raised to the 0, you're going to get 1 as your answer. All right. And like I said, you can try that with any number by building this list, like the 3s or even the 2s. I mean, it's the same list. It's the same idea. You're taking one of those multiples of 2 away by dividing it, and that's what you come up with. All right. And then negative exponents, I did hint to it a little bit, but let's go ahead and write that as a rule. So again, it's another one it's one of those things that's hard to say, but really easy to do. So anything raised to the negative power anything raised to the negative power is equal to or equals the reciprocal of the positive power. And again, that's a little bit tough to understand, but what we like to use in this case is our math writing, or our math, definitions. If I have a to the negative n, that's going to be equal to 1 over a to the n. And you can see that that was true with the whole list of 2s. You could build up the list of 3s over here and see that same thing is true also. Okay? And so it looks difficult, but really it's not that bad. Let's go ahead and look at some problems where we're going to simplify using some negative and 0 powers. So let's start with this one. Now what I want to do, what my overall goal is to do here, would be to write with just one exponent, and that one exponent only being positive. Okay, so I'm going to start off by, I have this k to the negative 4. I'm going to rewrite that as 1 over k to the 4th times 3k to the 7th. Now, keep in mind that anytime I multiply one, a fraction, I guess, by what really looks like just a whole number, I can kind of move that whole number into the numerator, and that's kind of a skill that we're going to be using a lot here. So really this is 3k to the 7th over k to the 4th. All right. And now I can use my quotient property if you want to, and rewrite it with, I mean, we have only positive exponents, so technically this could be an answer, but it's not in its simplest form. So the 3 is just going to be by itself. And this here we have k to the 7th minus 4. All right. And 7 minus 4 is 3. So I'm going to get 3k to the 3rd. And that'll be my final answer. And it's a lot simpler than this one. Like I said, this can be an answer, but it's not very simple. Okay, let's move on to the next one. So here I have some zeros. All right. Now when I'm looking at this, some people tend to think, and don't get trapped into this, but some people think that this 4 is being raised to the 0 power. That would only be the case if there are parentheses around this 4a. It's only a that's being raised to the 0 power. All right, so a to the 0, well, hey, I've got it right there. A to the 0 equals 1. And that, again, means anything to the 0 equals 1. So I get 4 times 1, and then I have my 3, and another a to the 0, and a to the 0 is 1 also. All right, and that's very important to keep straight. That it's not the 3, you know, this whole thing, people will just say, well, it all equals 1. It just, there's a 0 as an exponent, so they'll say it just all equals 1. It doesn't, okay, but there are no more variables in this expression. I just have numbers, and you can multiply that out. The ones don't change anything, you just get 12. Okay, let's move on to the next one. So in this one, there's a couple ways to look at it. The way that I'm going to start off looking at it is that I want to, again, distribute this 0 into every single term, and they're not even terms, sorry for saying that, I don't mean that. Every product, or every every factor is what it is. Things that are multiplied together are called factors. So I want to distribute that 0 into every factor of this expression. So we get 2 to the 0, x to the 4 times 0, if you remember the power property, y to the 3 times 0, and z to the 7 times 0. So really, it says to rewrite using only positive exponents. That's done in a way. And here's what I mean by that. So 2 to the 0, we know that that's going to be 1. All right. 4 times 0 in this exponent, well, anything times 0 is 0, right? So I'm going to rewrite that as just being 0. Okay. 3 times 0 is 0, and 7 times 0 is 0. Okay. So all those have exponents of 0. So x to the 0, well, that's 1. Y to the 0, that's 1. Z to the 0, that's 1. All right. So I have 1 times 1 times 1 times 1. We know that one. We get an answer of 1. Now, what you can use is you can use the fact that I'm raising this set of parentheses to the 0, and anytime 0 is on the outside of parentheses, this whole thing, I'm going to write it in a different color so you can see it, but this whole thing is going to be 1. All right. And that's just kind of the way that I sort of cancel things out, is just putting a line through it and putting a little arrow and saying what it's going to be. That whole thing just goes to 1, all right, because 0 times anything is 0. So that 0 exponent, sort of commands everything in that expression. Let's look at this last one really quick. Now, just like in the last one, I know that what I'm going to be doing, or what I should do, is probably distribute that -1 into every product. But really what it's doing is it's saying, and you can kind of think of, let's say just off to the side, that a, just like a in this case over here, let's say that a equals 2x to the 4th, y to the 3rd, z to the 7th. Okay? And so in this case we would have a to the -1. All right. Well, negative 1 just means put it in the denominator. So I'll have 1 over a. Okay, and this is sort of a quicker way. I wouldn't write either one of these steps. I'll show you what I'll write in a different color in a second. But what we get here is we just get 1 over 2x to the 4th, y to the 3rd, z to the 7th. That's my answer on that. So like I said, I would just simply write from here equals 1 over everything that's being raised to that negative 1. So 2 x to the 4th, y to the 3rd, z to the 7th. That's really what I would write because it works. That is my answer because everything is being raised to the negative 1 and not just bits and pieces. Okay, everything's being raised to a negative exponent, so it's all going to go down below. All right, and since it's a negative 1 and not a negative 2 or 3 or 4 or anything, the values of the exponents don't change. Okay, because 1 times 1 is 1. So that kind of works out for us. Let's go ahead and turn the page and move on. So we have some, wrong one. We have some tougher problems here. Some of these are very, very complex and complicated. And my biggest, I guess my biggest hint on these would be to simplify as much as you can before you start dealing with negatives or anything like that. But really our rules don't change on here. All I want to do is, sorry, brain fart. All I want to do is rewrite it using only positive exponents. Okay, so I'm going to look at this first one, and what I want to do, the inside of the parentheses is completely simplified. I have a negative there, but I'm going to deal with that in a second. I'm going to distribute that 4 into both products, or both factors again. So I have 2 to the 4th, and then I have r to the negative 4 times 4. So that's r to the negative 4 times 4. All right, we can start kind of cheating now because we already passed that last mastery challenge. Okay, so we can kind of use this as kind of side work, but 4 times 4 is 16, and so that's an r to the negative 16. Now in the same step, I'm going to simplify the bottom. So I have r to the 2nd and r to the 3rd. They're multiplied together. When we multiply with like bases, we add the exponents. 2 plus 3, so that's r to the 2 plus 3. And 2 plus 3 is 5, so that's r to the 5th. Now here's the quick way to deal with the reciprocal of the positive. All I want to do is I want to take this factor, since it's raised to the negative power, I'm going to drop it down below, and I'm going to change the sign on the exponent to being positive. And that's a quick way, that's a real good trick. So on the top I only have 2 to the 4th. On the bottom I have r to the 5th and r to the 16th. Okay, so notice how I just moved it into the denominator and made it positive. If I had a negative down below, I'd move it into the numerator and make it positive. It's a really good trick, saves you a bunch of time, and actually it saves you a step. So here we're going to have r to the 5th plus times r to the 16th. So we add those exponents, we get r to the 21st. Okay, and that's my final answer there. I can put a box around it and call it good. So let's look at the next one. All right, I'm going to, we kind of have two different things that we can do. We can either deal with the negatives, make all the exponents positive and then simplify, or we can try to, use our properties of exponents now and, maybe make our life a little bit easier. So what I'm going to do is I'm going to try to combine all these. Actually, no, my first thing I'm going to do is I know this entire piece is raised to the negative 1 power, so I'm going to put it in the denominator. And at the same time, I might as well, or no, let's just do that. This one's a pretty tough problem to keep a good strategy on. So that whole thing goes into the denominator. So we have 2b to the negative 3. Okay. Now I'm going to, I have this b squared, or b to the negative 2 and a b to the negative 3. I'm going to go ahead and sort of switch positions with those two because that's what my negative exponents do. So on the top I'll have 2b squared and b to the third. On the bottom I'll have the 2 and then that b squared right there turns into a positive exponent. And now we can look at what we have and cancel out what we don't need. All right. So it looks like on the top, oh sorry, that's a b cubed right there, because that's coming from right there. That's b cubed. So this one is a b cubed. Okay. Let's go ahead and just simplify and do a couple things at once here. So first off, I see that I have 2's that are the same, and I want to combine those two b's on top. So my 2's go away. I have b to the 6th, 3 plus 3 is 6, over b squared. And then I'm just going to go my 6 minus 2 and have b to the 4th. And that's my final answer. What I want you to do right now is go ahead and pause the video and try the next two. Okay, welcome back. Hopefully you got those done. I really wanted to give you a couple easier ones to try to warm up with on your own before I went ahead and given you some of these down below, because those are tough. All right, so here I have this piece that's all raised to the negative 1, so it's going to go down below. So on the top I have 2x to the 4th, and then on the bottom I have 2x to the 4th. I have the same thing on the top and the bottom. Those are all going to cancel out. Everything there, you know, I have the same thing on the top as the bottom. Then you just get a 1. All right. So pretty easy one there. Might have been a little too easy for you. Let's go ahead and look at this. The first thing I'm going to do is, I guess, simplify this part, because I do have a power raised to a power. I don't like parentheses. I want to get rid of those. Okay. So I have 2, actually, I'm going to move this p to the 4th up top while I do that. I know, a bunch of things going on at once, but you can do it. Okay, so up top I'll have p to the 4th, and I have that p that was already there. And on the bottom I have the 2. This is going to be negative 2 times 4, so p to the 8th. And then there's another p there also. Okay. And this is where it gets fun. So, oh, sorry, that's negative 8. There's negative 8 power down there. Okay. And so let's see what we have. I have those two p's are going to cancel. All right. I'm going to take this p to the negative 8 and move it up. So I'll have p to the 4th times p to the 8th on top. And the only thing left on the bottom is going to be that 2. And then I just simplify. 4 plus 8 is 12 over 2. P to the 12th over 2. All right, last 4 problems. They look really tricky, and I really need to. These are kind of those bring the pain problems. All right, you know, I'm trying to make you trip up on something, but let's go ahead and see what we get when we work this problem out. So the x term, or the x factor right here, goes to 1, and this whole thing down here goes to 1 because it's raised to the 0 power. I don't want to worry about it if I don't have to. Okay, let's get a closer look at this. All right, so I have on the top 2 times 1, but I don't have to write that. And I have x to the negative 1st all over 1. Not that I had to write that either. But I'm going to go ahead and now move that x to the negative 1 power down below. And we'll get 2 over x. Okay, I needed to get rid of my negative exponent. Okay, so looking at the next one, what's the easiest step? Well, anything to the 0 power just goes straight to 1. Okay, the next step that I would say is that I'm probably going to get rid of these parentheses, and I'm just going to do one thing in this step. So let's just go x squared on top, xy to the negative 2. You know, if you wanted to, you could move that up top right now, but I'm going to have a lot more negative down here. Well, maybe not a lot, but a little bit at least. Now that 4 out here needs to be distributed into everything, but it will get rid of my parentheses. So that'll be 2 to the 4th, x to the 3 times 4, which is 12, and y to the negative 4 times 4, which is y to the negative 16th. All right, still a bunch of stuff on the bottom. Okay, 2 of those things are y's and they're negatives. So I'm going to go ahead and move those up. It's negative, so I move it up. And let's just rewrite what we have. So we're going to start with the x squared. I have y squared, change the sign, and this y to the 16th, change the sign. On the bottom, I'm going to put my 2 first. So 2 to the 4th, there's an x, and there's an x to the 12th that didn't move. Okay. And now we just simplify. We're just going to be using product rule and quotient rule to finish this thing off. So I don't have any common x's up top, so that'll just be x squared. Y to the 2nd and y to the 16th, that'll be y to the 18th. On the bottom, I'm going to leave it as 2 to the 4th. I could figure out what that is, or I did at the start of the video, but I'm not going to worry about that right now. X to the 1st and x to the 12th will be x to the 13th. Okay. Now here's kind of a here's a little trick. Now I know, and I'm going to use a different color for this. I know that with this x and this x, I'm going to be going x squared minus 13. Okay, that'll be my power on the x. Well, 2 minus 13 is x to the negative 11th. Okay, now if I put that up top, I then have to move it down below. But I'm not going to do that. I'm just going to subtract it the other way. Okay, I'm going to go 13 minus 2, but I'm going to put it in the bottom. All right, so really what I'm doing is if you think about writing it all out, where I have xx, y, 18 y's, and then I have 13 x's on the bottom with the 4 2's, I'm just going to cancel out 2 of the ones on the bottom. And sometimes that helps people out, and it's a lot less writing. So on the top, all I'm left with is the y to the 18th, and then the 2 to the 4th, and I'm going to take 2 away from that, so it'll be x to the 11th. And that's my answer. Okay, nothing, all the exponents are positive, which is good, and so yeah, we're all worked out there. I want you to go ahead and pause the video and try these last 2 problems. Okay, welcome back. Hopefully you had a chance to get those done. Let's go ahead and look at what we're going to do to solve these. Now, remember, I like to get rid of parentheses first, so I'm going to go ahead and do that. And I do that by distributing that 4, so that'll be x to the negative 4th, and that'll be y to the 16th, times 2y to the negative 3rd. Okay? Now, any negatives, I'm just going to switch positions. All right, that's what I'm going to do right now. So I'm going to switch these 2, because they're both negatives. I'm going to move that y up. So I have x to the 4th up top, y to the 4th, oop, that looks like a y, and y to the 3rd. The 2 stays down below because it's just another factor. I'm going to lead off with that 2, and then I'm going to have my x squared and my y to the 16th, and that looks good. Okay. Now let's go ahead and use product property here. So I'm going to leave my x to the 4th for now. I have y to the 4th and y to the 3rd, which means y to the 7th, all over, and the bottom looks good. 2x squared, y to the 16th. Now remember, I'm always subtracting from the bigger one, and my answer is going to go there. So I'm going to subtract 2 from the top on the x's. So that'll be x squared. And on the and for the y's, I'm going to subtract it from the bottom, and I'm going to put my answer on the bottom. So 16 minus 7, that is 11. No, 9. Sorry, it's late. So, and since the bigger number's on the bottom, I keep my positive exponent on the bottom. That's what we get. All right, and one last problem to round this out, and we'll be good to go. Tough one, I know. It looks really tough, especially if you think about distributing that 4 to everything. What I would do is I would simplify inside the parentheses first. Okay, I have v to the third, and a v squared, and a v. So 3 plus 2 plus 1. So that's going to be v to the 6th. I only have a u squared up top. Down below, I'll have a v to the negative 8th. Okay, and that's all going to be raised to the 4th power still. I haven't dealt with that yet, but I will. I'm going to move my v to the 8th up. So we have 2v to the 6th. I'm going to throw it right there, v to the 8th, and u squared. That's still all raised to the 4th. We haven't done that yet. Use product property right there. So that'll be 2v to the 14th, u squared, to the 4th power. And now we distribute that 4, since everything else is, is its own factor. So we'll have 2 to the 4th, and that's v to the 56th, because 14 times 4 is 56, and that'll be u to the 8th. And that's your final answer. Okay. Hopefully you got something out of it today. I know it went a little bit long. I apologize for that. But they are difficult problems, or not difficult, but time-consuming problems. All you're doing is moving variables up and down and around and whatever direction they may be. But go ahead and stick to it. Make sure you show your work, and good luck on the practice application and mastery challenge. So we're still covering rules of the gym. Number 4, if you remember, is be careful of box jumps. Number 3 is to keep your balance. Number 2, control your excitement. That's very important. Don't get too excited. You might have a hard time standing up.
Get it done, come on.
Okay. Here we go, come on. Get up, get up, get up, get up, get up, get up. Yeah, there it is. Nice.